Topic 1 and 2. We are about to dive right into one of these questions from the homework. Really taking it to the homework. So this is number 3 from the homework, okay? And it's asking us to predict the products of this reaction between potassium carbonate and barium chloride. First thing I'm going to do, I'm going to write what these reactants look like. Some of us are actually skipping that step, and that's not okay, okay? Potassium carbonate. Potassium carbonate plus barium. I know barium is Ba.
I thought it was
chloride. B is boron.
Oh.
You moron. So that's what it's going to look like. Next thing I got to do, check your periodic table and make sure you have your charges. Okay, so if you have your charges, you can do your subscripts. Potassium's charge is +1. Carbonate's charge is -2. +1, -2. We crisscross those charges, and this 2 ends up down here.
Crisscross applesauce.
Okay? Now barium is +2, chlorine is -1. Crisscross applesauce, bingo, bango, bomb. Okay?
Bada bing, bada boom.
K2CO3 plus BaCl2. That's what our reactants are going to look like. Want to take over with the products?
I would love to. I thought you'd never ask. Okay, so we got the formulas for the reactants. Now, to predict the products, what we need to do, this is a double replacement reaction, right? So the cation and anion of one compound are going to dissociate and combine with the cation and anion of the second compound, right? So I'm going to find my cations that are positive, right? They're positive cation. Usually they're metals. Here they are. Potassium's one. I'm going to circle it. Barium's the other. I'm going to circle it. I'm just going to draw a little arrow to show that they switch, right? They're swapping. So, my products, I'm going to list them over here. I'm going to leave a little longer this time. Are going to be potassium paired with chloride. So we're going to have KCl. And we're going to have barium paired with carbonate, right? So it'll be, how much room do I have here? Might be a little too big. Barium carbonate, right? And now I'm done, right? Mr. Smith, am I done?
No!
No, wait, there's more. Okay, cool. So now we need to do the same thing we did over here, right, Jen Dad?
Yeah.
And we need to find the appropriate subscripts based on the charges for our products.
Cool.
Now, before we do this together, okay, I'm going to point out number 1 error, okay, that me and Mr. Smith and Jadea have been seeing this past week, which is do not take the subscripts from the reactants and just put them over on the product. So just because there's a 2 on this K doesn't mean I'm going to just put a 2 on this K, okay?
Yeah.
Eliminate the subscript and find the new subscript based on the charges of the products.
Coming up with a whole new subscript.
Whole new subscript. We're changing the game, okay? So, the way I do that is the way we did it over here, okay?
Yeah.
Charge of potassium is what, Jindea?
+1.
What's the charge of chlorine?
-1.
I should say chloride, because it's the ionic form of chlorine. So I'm gonna crisscross applesauce, right?
But you don't really need to because they both cancel out anyway.
Oh, Jindea says we don't need to because they both cancel out anyway. That's why she's an A+ student. Give me a high. Alright, awesome. So we're looking for the ratio, right? The charges are already balanced, so we don't write subscripts. Good to go. Now let's do barium carbonate, which I don't know if this is in the camera.
It is.
Alright, cool. Barium has a +2 charge, as we know. Carbonate also has a -2 charge. I'm going to do my crisscross rule, and I'm going to write 2 2s here, right, Mr. Smith?
Yeah, you can write them there, but you got to do something since they're the same number.
What do I do?
2 and 2, since they're the same number, you can just simplify them. They end up just being 1. We can just cross them out. Eliminate them.
Alright, so they're gone because we're just looking for the ratio, right? 1 to 1. Beautiful.
So these are our reactants, and these are our products. That's what they look like. We got our correct substrate, we double checked, okay? The last step is you need to balance your reaction, okay? Let's do that
Now.
by starting with our reactants. First thing we're gonna do is list all of our components. We've got potassium, carbonate, barium, and chlorine.
Wait, Mr. Smith, why did you keep CO together? Why didn't you separate those?
Because CO3 is a polyatomic ion, and since it's a polyatomic ion that I also see on my product side, I can keep it together just because it's easier to balance that way. So we have potassium, carbonate, barium, and chloride. All right, on my reactant side, we've got 2 potassiums, 1 carbonate, 1 barium, and 2 chlorine. Jinde, on our product side, how many of each do I got?
1 for each of them.
Boom, boom, bingo, bango, right?
So you just put in 2 in front of each.
Hold on, before you, because you're right, but what's not balanced yet?
The product side.
Which components?
Specifically.
What do you mean?
And potassium, right? So these are both 2, these are both 1, right? We want to change those to match the reactant side. I'm going to do that by putting a 2 in my coefficient.
That's gonna
I can't change these numbers without changing my coefficients. So since this is 2, oopsies, I've now got 2 potassiums. Since this is 2, I've now got 2 chlorines. 2, 1, 1, 2, 2, 1, 1, 2. Did I make a mistake? Oh, I forgot to even write the number there. Look at that. Sorry. They're balanced.
Balance.
Yeah, double check, make sure you got it all. This is 1, 1, 2, 1. Have a great day!
Go get them.
Let's turn